Hello, this is Arnie Mangolds from C2 Innovations. The following is an update on the sea otter family of amphibious bottom crawlers. We have a range of systems from the small sea badger, which carries about a 70-pound payload, all the way up to the sea beast, which can hold almost a half a ton of payload plus pull a sled. All of them are rated to 100 meters in depth and have about a 10-mile range underwater. Since all the vehicles can be shore-launched, even in rough conditions, the crawlers potentially eliminate costly boats and crews. Weather and sea state independence allows surveys to be performed when it's needed, rather than when conditions allow it. Now, a bottom crawler provides a unique look up and look across perspective. Close contact with the ground provides information that no other platform can achieve. We're steady in constant contact and in very close proximity. Since buoyancy, weight, and volume are not an issue, the vehicles can be loaded up with instruments measuring a broad spectrum of parameters in a single trip. Now, while it can do many things, our immediate focus has been on developing a good surveying method. Using the ground surface as a reference point eliminates a lot of transition errors and calibration or correction factors. In the simplest form, we just attach a mast and stick a RTK sensor or an optical prism on top, and we just drive it through our routes. The data can be collected on board, or it could be transmitted back by an RF link, which is what's in that orange buoy. The practical limits of a mast are about 7 meters or 21 feet. But in deeper waters or in heavier surf, a mast really becomes problematical. So we developed a method where we use a combination of onboard sensors to measure the gradient and integrate that over distance. That allows us to eliminate the mast completely and get the same kind of results. Comparing RTK with our what we call the integrated gradient method has allowed us to get very good matchups. You can see on the left hand the red and the white being our profile. We tend to agree within 2 centimeters over 650 meter ranges. On the right is a statistical comparison of the data, and we're getting very good agreement with an R squared of 0.938, which really represents half a centimeter in difference between RTK and our system. And that's over repeated runs. We have a precision pressure gauge on board as well, which is kind of convenient because we can measure wave height, shape, and period as a function of distance ashore. And what you can see there is the vehicle entering into a surf. Now this slide shows 5 overlaid traces. The white is RTK on the mast, and the red is pressure. The wave action is clear on the red because you're getting all those overlays. You can see the width of the swash zone, and you can clearly define where land or where the water-land interface exists. But what it really demonstrates, first of all, the pressure is remarkably similar to the profile from the RTK. But it really shows you how we can take a seamless measurement of topography or bathymetry from land onto sea, getting environmental factors and all that stuff without any interruptions or artificial boundaries. Since the system is fully autonomous, or can be, or you can do a manual control, you can cover a lot of ground quickly. 10 linear miles can be mapped in a single shift with a one-man crew. The picture on the left was done in 1 hour with one person. All that data is compatible with the common software mapping programs such as HiPAC. Previously I mentioned that we could do profiling of rivers as well. Here we did Duxbury Crossing, which is about 675 meters far shore there. And we measured the bathymetry, the bank profiles. We used a Nortec ADCP to measure the current flow. We had cameras on board to see what kind of life was down below, as well as periodically we raised a penetrometer, which measured the California bearing ratio levels, so we could get soil strength anywhere along the river for that entire profile. So the system is available for sales. There are data as a service. We're looking for partners and team members, because we always have we have a brand new capability that offers a lot of opportunity.